Okay, so looking at this, okay, the remainder theorem, what does it say? The remainder theorem says that if you take what you're dividing by, right, and you plug it in to your equation, it'll give you what the remainder is for when you divide this into your equation. So first thing we need to remember is that what I'm dividing by needs to be in this form, x minus a. And then a is what I plug in. But see, this thing right here is not in that form. That is x plus 5. So I need this x plus 5 needs to be looked at as x minus a negative 5. Now it's in that form. Does anybody have any questions on getting x plus 5 to look like x minus a? All right, so now that we know what our a is negative 5. So now I'm going to plug negative 5 into this equation. Well, I don't want to say equation, this expression. So that's going to be negative 5. Say that again. Okay, negative 5 minus 5 times a negative 5 squared plus 2 times a negative 5 minus 8. So once I simplify this, that's going to be the remainder that I would get. Well, negative 5 to the third power is negative 125 because it's negative 5 times negative 5 times negative 5. Then here, negative 5 to the second power is positive 25, but then positive 25 times a negative 5 is another negative 125. Then 2 times negative 5 is negative 10, and then I've got negative 8. So negative 125 plus negative 125 is 250. 250 plus 10 is 260. 260 plus 8 is 268. So that's a negative 268. And that would be my remainder. Does anybody have any questions? All right, so this second one, I'm going to leave for you. So next. So now. So next, it says simplify the radical expressions. Well, these are all radicals. Adding or subtracting radicals is kind of like adding or subtracting variables. You need to have the exact same thing in order to add or subtract. For instance, if I've got 2x plus 5, that's as far as I can go because this has a variable and this don't. If I have 2x plus 2y, that's as far as I can go because now even though I've got variables, the variables are different. But if I have 2x plus 5x, now I can combine those because the variables are the same. You know, I can think about it like saying 2 apples and 5 apples. That's 7 apples. But then here, 2 apples and 2 oranges, that's just a bunch of fruit. Can't mess with it. Okay, so next. If I'm looking at radicals, I want to simplify those radicals so that they look closer alike, so they look alike. Well, I'm going to start with the smallest one because that kind of gives me the clue on what I need to do with the rest of them. So if I look at this, 32, what two numbers do I multiply to get 32? 16 and 2. Now, I could have said 4 and 8, but 16 and 2 works out better, and let me explain why. 16 is a perfect square. So if I think about it like this, I break it down into these two numbers that multiply to give me that number, and then I take the square root of them. The square root of 16 is 4. The square root of 2 I can't really simplify, so the square root of 32 simplifies to the square root, or excuse me, 4 times the square root of 2. So now that I simplified that, that means in order for me to add or subtract, these two things need to have the square root of 2 with them, or I can't combine. Does everybody follow me? Radicals, when you're adding or subtracting them, the radical has to be exactly the same, or you can't combine them. You can't add or subtract them. So because this first one has radical 2, that means in order for me to add or subtract, these need to have a radical 2, which means breaking them down, I'm going to think like, okay, well, these are even numbers, so I'm going to say 2 times what gives me this? Well, if I break this down, 2 times what gives me 128? 64. 64 times 2. And it just so happens that 64 is a perfect square. So when I take the square root of both of these, I get 8 and the square root of 2. So then over here, I do the same thing. If I got 2, 2 times what equals 200? 100. And guess what? 100 is a perfect square. So I'm going to take the square roots of both of those, and I get 10 square root of 2. Now look at what I got. I got 4 square root of 2, 8 square root of 2, 10 square root of 2, right? All of them have the square root of 2, so now I can add or subtract them. The same way if that was 4x, 8x, and 10x. So now I'm going to rewrite the problem the way it is. That's 4 square root of 2 plus 8 square root of 2 minus 10 square root of 2. Now see, I can do this because 8 square root of 2 plus, 4 square root of 2 plus 8 square root of 2 is 12 square root of 2. And then minus 10 square root of 2 is just 2 square root of 2. And that's my final answer. Has anybody got any questions? Okay. So let's look at the next one. Remember, this one's for you. So here, it says find the zeros with multiplicity. Remember what multiplicity is. I mean, to just break it down simply, it's kind of like how many times you repeat. You know, right here, I've got x plus 3 to the second power. So that means I've got x plus 3 times x plus 3. Here, I've got 2x minus 1 to the fourth power. Well, I don't feel like writing it, but that's 2x, I'm sorry, I said plus. 2x minus 1 to the fourth power, so there's 4 of them there. And then here, x minus 7 is to the third power, so there's 3 of them there. So let's talk about what my zeros are. So x can equal -3. Because if I just think of this, what x make that 0? -3. And that's got a multiplicity of 2. This next one, I'm going to work it out over here because it may not be as easy to see. 2x minus 1. I want to know what value of x makes that 0. So right here, it was pretty easy to see x plus 3 equals 0. Okay, x is minus 3. It might not be that easy to see here. So what I'm going to do is I'm going to just write this equation out and solve it, by setting it equal to 0. So first I add 1 to both sides. So now that's 2x equals 1. Then I divide by 2. And now the 2's cancel off. X equals positive 1/2. So then this 0 is x equals 1/2 with a multiplicity of 4. And then finally, this last one, I got x equals positive 7 with the multiplicity of 3. Say it again, sir. You're right. I didn't, but I didn't put with though. I'll say this, that I'm sure somebody's going to ask me, Fur, if you don't do the multiplicity, yes, it's wrong and you get points off. If you give me this, you might get half a point, depending on how much these are worth. I might make them worth 3 points, or 6 points. That's 2, 4, 6. So this is 1 point, that's 1 point. Does anybody got any questions? X squared minus 1 is actually x plus 1 times x minus 1. That is the difference of squares. So that simplifies to these two things. So each one of those has a multiplicity of 1. No problem. Does anybody have any questions on number 3 before we call it? So 2 or 1, any questions? Okay, then let's call that.